I am Kalyan Reddy Daida and I will be the instructor for you on this Azure AKS Kubernetes Masterclass and Azure DevOps and then Terraform course. So to start with, we are going to see this course in 4-dimensional way. So one is Kubernetes core concepts, and second is Azure services integration with AKS clusters. Okay, AKS is nothing but Azure Kubernetes service. In addition, Azure DevOps for these Kubernetes workloads running on AKS cluster, and also the Terraform. So how to provision these Azure AKS clusters using Terraform. So these are the 4-dimensional way we are going to look into all these concepts. So with that said, from Kubernetes concepts perspective, so we are going to cover pods, replica sets, deployments, and then services, load balancer services, external name services, IP services. In addition, from storage point of view, we are going to look into storage classes, persistent volumes, persistent volume claims, and then volumes. So adding to that, we will also understand about Kubernetes secrets, limits, resource quotas, namespaces, and in addition to that, in a very detailed manner, we are also going to look into Kubernetes RBAC, role-based access control. So as part of that, we are going to create role bindings, roles, cluster role bindings, and we are also going to use these in combination with Azure AD integration by creating the users in Azure AD, and then using the roles assigned to them, we are going to access our Kubernetes resources. In addition to that, we are also going to look into Ingress services in a detailed manner. So Ingress SSL with Let's Encrypt, and then Ingress context path based routing, Ingress domain name based routing, and Ingress with external DNS. And moving on, we'll also look into horizontal pod autoscaler and also the cluster autoscaler. So autoscaling concepts also we are going to cover. So in addition to that, the fundamentals of Kubernetes we are going to look into in such a way that first we will implement these pods, replica sets, deployments, and then services in a imperative way using the kubectl command. And then using the live template writing, so we are going to do the same thing in a declarative way using YAML. So like that, we are going to learn lots and lots of Kubernetes concepts, and in combination with these Azure services integrated with AKS. We are going to look into Azure disks, Azure MySQL, Azure files, and then storage accounts in combination with Azure Kubernetes clusters. As part of that, we are also going to learn about Azure public IP, standard load balancers, virtual networks, and then subnets. This Azure AKS cluster, we are going to integrate it with Azure AD. So for that purpose, we'll also be having the concepts related to Azure AD, AD groups, and then AD users. In addition to that, from Ingress standpoint, we are going to also have a external DNS which will auto-register our DNS name when we deploy the Kubernetes workloads, okay? Kubernetes services on Kubernetes. So for that purpose, DNS zones concept also we have included. So we are going to dedicatedly see 3 types of use cases for Azure Container Registries for building and pushing the Docker image to Azure Container Registry, and how to integrate this Azure Container Registry with Azure AKS, direct integration, or with service principal. So all those things we are going to look into. From there, we'll move on to Azure DevOps, Azure build and release pipelines, and Azure container instances with virtual nodes. So these concepts also we are going to look into. So from Azure DevOps perspective, we are going to provision our workloads on our AKS cluster using Azure DevOps build and then release pipelines. And so running the workloads on the virtual infrastructure, which is nothing but serverless infrastructure, we are going to use Azure Container Instances virtual nodes. Moving on, we are also going to create Linux and then Windows node pools and then explore those things in a production grade level. And we are also going to look into Azure Managed Service Identity in detail, how it is going to be useful in combination with this Azure Kubernetes service. And overall, this AKS cluster, we are going to use underlying workloads are Azure VM scale sets. Okay, the instances will be under Azure Virtual Machine scale sets. I've seen the 2 dimensions now. So let's see the third dimension is Azure DevOps. So from Azure DevOps perspective, we are going to build and push Docker images to ACR, and those workloads we are going to deploy to Azure Kubernetes clusters. So we are going to write the pipelines from the scratch, which is nothing but from starter pipelines onwards, we are going to write it in 5 phases. And after completing the CI pipelines, which is nothing but continuous integration pipelines, we are going to move on to continuous delivery or deployment pipelines, which are nothing but release pipelines. So as part of that, we are also going to implement dev, QA, staging, and then production environments. So once the third dimension is completed, the fourth dimension we are going to focus on Terraform. So from Terraform perspective, it's not just provisioning a AKS cluster with Terraform. We need to understand the foundation and then fundamental concepts of Terraform. So that for that purpose, we'll have a dedicated section on Terraform command basics and also Terraform language basics. And once those are thorough for us, we will move on to provisioning the production grade AKS cluster using Terraform from our local desktop. So once that is clear for us, then we'll move on to the provisioning AKS cluster using Terraform and then Azure DevOps. So these concepts we are going to cover in a 4-dimensional way in this course. So to move on, these are the GitHub repositories which have the step-by-step documentation of all the work whatever we performed as part of this course. So to view it on a very high level, so we can go here, and if we go to this main repo, whatever it is, Azure AKS Kubernetes Masterclass. So every concept whatever we have implemented here from 01 to section 25, everything is documented in a detailed manner. For example, if you go to any of the sections like this, so you can see in each step what you are going to do is detailedly documented. In addition to that, you will also find the Kube manifest folder in everywhere. So all the manifests whatever you are going to execute also will be documented in a detailed way. And then just by forking these repositories, so you will be able to download at your side and then start using these entire use cases whatever is implemented as part of this course. So these are the 4 repositories. This is for the DevOps. So we have 4 pipelines created and those information, okay. And this is for the Terraform pipelines. So entire Terraform manifests were documented here. So 11 manifests which are written in a very detailed manner. So these are the things. And this is the Docker fundamentals step by step. So moving on, also going to have a course presentation with 250 plus slides located at this location for depicting all the architectures and then designs implemented as part of this course. So here completes the course, very high level introduction, but few of the students asked me about also a detailed introduction for them to understand what they are going to learn in this course, okay. So from here on, few more slides about what you are going to do as part of this course will be explained. And if you are satisfied with this level of introduction, then you can move to the next lecture and then continue with the course, or we can continue further about this course and then what we can achieve from this course. So moving on, so we will initially start with Docker fundamentals for close to 1 hour and understand about what is Docker and then how to create a Docker image and then how to push the Docker image to Docker Hub, how to download that image from Docker Hub and then run it locally. So all those things we are going to look as part of Docker fundamentals. And then we'll move on to Kubernetes fundamentals. From Kubernetes fundamentals perspective, we are going to take this in 2 approaches, okay. So one is imperative way and then declarative way. So in imperative way, we are going to learn using kubectl the entire pod, replica set, deployment and then service concept. And then we'll move on to declarative way and also learn those things by writing the YAML definitions in a live template writing mode. So once the fundamentals are thorough for us and then we have strong background on Docker and Kubernetes, now we'll move on to the next steps, okay, of storage. So from Kubernetes storage perspective on Azure AKS cluster, how you are going to use the Azure disks as your persistent storage. So you are going to look into. As part of that, again, you are going to learn the concepts like storage class, persistent volume claim, persistent volumes, deployments, load balancers. So all these concepts you are going to learn as part of this section. And from there, we'll move on to the next level. So using this Azure disks, there will be some downsides. So how you are going to use the Azure MySQL database as your persistent storage as an external service using external name service from services concepts in Kubernetes, and how you are going to implement that for your Kubernetes workloads running inside the Kubernetes cluster to access the external Azure MySQL database you are going to implement. From there, you will move on to the Azure files. Okay, so this is another storage concept in respective Azure cloud. So how you are going to use Azure files as your static content storage for your Nginx pods. So you are going to understand and then implement it. So from there, you will move on to Ingress services. Okay, so how you are going to understand the Ingress basics and then implement the context path based routing in Ingress. So if request comes to /app1, it need to go to one app, /app2 another app, and then if it is / it need to go to another app. So like that, how you are going to implement Ingress service with context path based routing, you are going to learn. After that, you will be in need of domain name based routing in Ingress. So for that purpose, you will use the Azure DNS zones concept here, and then if you have any registered domain anywhere, so you will delegate the domain to Azure cloud and then leverage Azure DNS zones to move on with implementing the domain name based routing in Ingress. Okay, so example, like if your URL name is eapp1.kubeoncloud.com, it need to go to one application. If it is eapp2.kubeoncloud.com, it need to go to another application. If it is eapp3, it need to go to another application. So these concepts, domain name based concepts, you are going to implement as part of this section. From there, you will move on to implementing the external DNS and then SSL with Let's Encrypt. So if you see here, so you have implemented the domain name based routing, and also you ensured that you used the external DNS here, which means the eapp1, eapp2, eapp3, these domain names will get automatically DNS registered using this external DNS. So that also you are going to implement. Then you will move to SSL with Let's Encrypt. So automatically a certificate need to be generated, certificate signing request, and then submitted to Let's Encrypt. And then you will get that approved certificate and then deploy to your pods, everything in the background automatically. And renewal happens, that also happens in the background automatically. So how you are going to implement that in your Ingress service using Let's Encrypt, you are going to learn here. And from there, we will move on to some more fundamental concepts of Kubernetes. So you learn about Kubernetes, requests and limits, and namespaces and their DNS names, and then you will move on to the next topics of Kubernetes limit ranges, resource quota, and finally you will land in Azure AKS virtual nodes. So how to run your Kubernetes workloads in Azure cloud on serverless infrastructure is nothing but it is using virtual nodes. So you are going to implement these virtual nodes, means like you need to spin up these virtual nodes and then run your workloads on virtual nodes. So for that purpose, you are going to implement a mixed mode deployment using virtual nodes, which is nothing but your MySQL pod you are going to run on regular node pools, and user management pod, which is nothing but your Java application, you are going to run on virtual nodes, and then implement this mixed mode infrastructure here and then test it. So the users can access your user management application from here, and then it comes here and then goes to MySQL cluster IP service to your MySQL pod to Azure disks. Okay, so this whole thing you are going to implement with virtual nodes, mixed mode deployments. So moving on, the next concept is going to be Azure Container Registry, right? So how you are going to have the Azure Container Registry integrated with AKS. Okay, so there will be direct integration. If you have only one repository, you can directly integrate that to your AKS cluster with the standard documentation. But there are scenarios where you will have multiple Azure Container Registries in your organization. So how you are going to handle that also, we are going to see using service principles. So you are going to build and push a Docker image to Azure Container Registry, and you are going to access that respective Azure Container Registry image, download to your respective Kubernetes cluster, and then make it up and then access it. Okay, so all those things as part of these two sections we are going to look into. And another thing here is, so how you are also going to run your workloads, right, on Azure virtual nodes, and then when you are using the Azure Container Registry as your Docker hub. Okay, so at that point there are some limitations, and then how you are going to overcome those limitations and then use it also, you are going to see inside this respective use case with virtual nodes. And then moving on, you will start with Azure DevOps pipelines for building and pushing your Docker image to Azure Container Registry. And then after that, how you are going to deploy that application to AKS cluster. So once that is done, you are going to focus on key concepts of Azure pipelines, which are nothing but jobs, agents, steps, all these things you are going to understand, stages in detail. And then you are going to also understand about these things in a hierarchical manner, how these stages, jobs, and then scripts come into the picture. And from there, you will implement a semi-customized pipeline and also a fully customized starter pipeline in a detailed manner, so that you will get the complete picture on starter pipelines from scratch, how you can write the Azure pipelines for your AKS cluster workloads to be deployed. And from there, so you will also implement the release pipelines. Okay, so release pipelines are continuous delivery pipelines. So far, whatever you have seen, the starter pipelines, all these are continuous integration CI pipelines. So you will also move on to continuous delivery pipelines and then implement those continuous delivery pipelines, which are also called release pipelines. So you are going to build a Docker image and then push it to your Docker Hub or whatever the Azure Container Registry using the build pipelines. And from there, you will have these release pipelines deploying your application to dev environment, which is nothing but dev namespace. And after approval, again, you will deploy to QA namespace, after approval to staging namespace, and then production namespace. Instead of using multiple clusters to save the cost, we have used multiple namespaces with single cluster and then implemented the release pipelines here. Okay, so this one you are going to do it in a detailed manner. So after the implementation, it is going to look like this. Okay, so whatever the pipeline you are going to build, so dev, QA, staging, and then production, it is going to look like this. So these are the releases you are going to implement in the release pipeline. So from there, you will move on to the HTTP application routing add-on. So this is a non-production use add-on as on today from Azure, which automatically installs the Ingress and then external DNS. So you are also going to get good hands-on on using this add-on and then how you are going to deploy your applications and then use it. From there, here start the concept of fundamentals about how to access multiple clusters from your local desktop using kubectl. So there you will try to understand about these AKS get credentials and also about this kubectl config view, config current context, and then config use context. All these things you are going to learn. In simple terms, multiple clusters access from our single desktop terminal. How we are going to do? We are going to learn that fundamental section. Okay, and moving on from there, we'll move to Azure Active Directory authentication for AKS admins. So for our AKS cluster, if we integrate it with Azure Active Directory, so all my administrators of my AKS cluster can access, will be a user in Azure Active Directory, and then whenever I have a new user, I can add it to the Azure Active Directory users, and then he will be able to get the access to this AKS cluster when that user is assigned to this K8s admins group. So this entire integration we are going to do. From there, we will move on to Kubernetes RBAC concepts. Okay, so we'll understand those RBAC concepts fundamentals perspective and also implement them in combination with Azure AD integration. So as part of that, we are going to understand what is role binding, cluster role, and then cluster role binding in detail, and implement those use cases in combination with Azure Active Directory, right? So when you have a access is granted, so you can see that, so access granted will be for those respective resources in your cluster, and when you don't have the access, so it shows that access is denied. So all those things you are going to look into, means like role-based access control at the granular level, how you are going to implement using these 4 YAML manifests, okay, which is nothing but cluster role binding, cluster role, and then role binding. So you are going to see in detail. So this is about cluster role binding and then cluster role. Here role and role binding, and here cluster role and then cluster role binding. So these also you are going to look into in detail. From here, we'll move on to autoscaling concepts and then implement the cluster autoscaler and also horizontal pod autoscaler. From there, we'll move on to the implementing the production grade clusters or creating the production grade clusters for Azure AKS using Azure AKS CLI. So using the CLI, how you are going to create a production grade cluster involving all AKS cluster. So surrounding whatever you are seeing, all these things are required for it to implement a production grade cluster. So how you are going to involve all these things and create a cluster? So we are going to implement that in detail. So first we'll create a AKS cluster, then we'll create Windows and Linux user node pools, and then finally deploy all the 4 types of applications into these node pools, and then understand in better all the concepts from AKS cluster perspective. This picture shows that how you are going to create the AKS cluster using CLI, and after that, once the system node pools are created, we create the user node pools of type Linux, user node pools of type Windows, and also virtual nodes using Azure container instances, and then finally deploy 4 types of applications, and then app 1, app 2, app 3 and app 4, and then act things and then test it. So this is another next level implementation for us. From here we'll move on to something called Terraform, right? So we'll learn the Terraform command basics and then language basics, and then implement this cluster, which is nothing but, so provision a cluster, AKS cluster with Linux system node pools, Linux user node pools, and then Windows user node pools. Okay, as a Terraform developer using Terraform CLI, you are going to provision all these things. So as part of that, you are going to create a close to 12 manifests in detail. So if you go here from Terraform perspective, so you are going to write the commands. If you see here, so all these Terraform manifests you are going to create, including the Azure AD integration, including the log analytics for monitoring, and all these things you are going to implement. Once you provision your Azure AKS cluster using Terraform from your local desktop, which is of production grade, so now you will move on to using the same Terraform manifest. So using Azure DevOps pipelines, so you will go ahead and then provision the Azure AKS clusters both in dev and then QA environments. So let's go back to our Google browser and come to here. So if we come here, so these are the pipelines for our Terraform. So we'll implement the Terraform validate job and provision the Terraform dev environment, and then also provision the dev QA environment. So once provisioned, they do look like this in the environment section, dev and then QA environments. So using the pipeline, so you can provision both. You can first validate the Terraform manifest, and if any issue, so then immediately fail the pipeline there itself. If all the validation, Terraform validate is successful, create a dev cluster and then also create a QA cluster. So using Terraform init, plan and then apply, so you can create all those things. So this is about the Terraform Azure DevOps pipelines. In the same way, we have discussed about the Azure DevOps for Kubernetes workloads. So here you can see custom 1 and then custom 2, which says that you are writing your pipeline from the scratch instead of using the default provided pipelines. Okay, so you will implement these things for your Kubernetes workloads, and these are the release pipelines you are going to implement. Okay, so all these things we are going to do as part of this course. So this completes the introductory part of this course, and in our next lecture we'll move on with the implementation of this course. So I'll see you in the next lecture. Until then, bye bye. Thank you.